Okay, up and running. Let's get this centered. All right. So I'm going to do about 35 to 40 problems. Some parts some of the questions have more than one part. So it's going to be quite a few problems. So I don't think I'm going to talk too much because I know that when I do that, when I get a little tired, I start to get very careless these days in my advanced age. Yeah. And so I think I'm just going to do the problems and you pause the video. It's just for practice this is post midterm in second half of the semester questions added on to what we were working on in the first half, which we will continue to work with. Well, we don't stop working with those problems. Okay, so we're trying to get a deeper understanding. But this particular video is just going to be me doing the problem. So you pause the video, try it. As I said, I'm not going to talk about them much. Already done that in a lot of the other videos. So just going to get some practice in. Because if you're going to get good at math, it's going to take some reps. So let's get some reps. All right, so I'm going to sketch V-shaped down. 3 is the critical number, makes absolute value of 0. 3 to 7, I'll put a 0 in. So that gets me minus 30 plus 7, minus 20, 23, I believe. Not going to check these. So let's hope that I'm correct piecewise. So let's look at our graph, which was g of x. I just called it y, but I'm not going to change it. Keep going. Increasing, then decreasing. I'm going to use x minus 3 plus 7. I'm going to use x minus 3 plus 7. I know that when x's are less than 3, I'm on the left side, which is increasing at a 10 to 1 rate. And you can multiply that out, and you'll see that that's true. And therefore decreasing at a minus 10 for x's that are greater than or equal to 3. Now I'm going to use those pieces to solve for negative 33. I don't have to use both, but I will. So on the left side, when does it equal negative 33? Negative 40, negative 4, add 3, negative 1. Over here, negative 10, x minus 3 plus 7 equals negative 33, negative 40, positive 4, positive 7, minus 1 plus 7 divided by 2 equals 3, so I think I'm probably okay. We've got two values here, negative 1, positive 7, and what am I going to be greater than? Should be true, false, true. And you can check that to make sure it works. I'll check it with just a number bigger than 7. I'll throw a million in here. Minus 2 million, I think we can safely say is less than 33. All right, so domain, solve domain the same way by finding the critical numbers. Don't spill that coffee there, Jimbo. All right, so what's critical? There's 3 critical numbers. One of them is 0, one of them is 1, and one of them is 10. Can I use numbers bigger than 10? No, I cannot. I cannot put, say, 11 in there. That's the square root of negative 1. It's not going to show up on the Descartes coordinate system. Can I use numbers between 1 and 10? Let's use 5. ln of 5 exists. The square root of 5 exists, so yes. Can I use 1? The ln of 1 is 0. The ln of 1 is 0, and I cannot divide by 0. So no, I cannot use the number 1. The numbers between 0 and 1, they're fine. We know numbers between 0 and 1. And if I put a half in here, that's fine. And ln of a half, negative 0.7 roughly. So yes, we can use those. Can I use numbers less than 0? Can I use 0? No, ln is undefined. It's asymptotic behavior. So therefore, and I have to make sure these values are positive, so no. So what's our answer? 0 x values that are 0 to 1, can't use 1. That's a comma. Union 1 to 10. All right, I'm going to just do this with a graph. We're practicing our graphing because that way we can tell if grandma's accelerating, if she's heading north or south, if this becomes a velocity curve. All right, 5. Odd exponent, root negative 4. Throw a big number in. Big, big, big. I get a big number out. Boomity, boomity, boomity. what it looks like. What am I, bigger than or equal to 0? Well, it sure looks like negative infinity to -4. -4 works. Union, 0 works. We'll need a comma there. Union, 5 works. All the way to infinity. We will get truth, justice, and the who knows what country kind of way. All right, what do we got here? Sign chart works great here for greater than or equal to 0. -3 critical, +4 critical. Can I use numbers bigger than 4? Yes. Can I use numbers between -3 and 4? I can't because I know there's sign changes. You can check that. That's going to be no. -3, I can't divide by 0. And then there's a sign change, so that's going to be a yes. So when is this thing bigger than or equal to 0? Negative infinity to -3. -3 doesn't work. 4 to infinity does. Hopefully I'm keeping the pace up. Sketching this. X-intercept 4. 4 gets me 0. Y-intercept -20 thirds. -20 thirds when I plug in a 0. Asymptotic behavior at y equals 5. Both sides. You put big numbers in, you're going to see they're about 5. They're about 5-to-1 ratio. I guess I'm done. It's got to do this. No other x-intercepts. Where's the asymptote? -3. So I got to put that in first. X equals -3. So whoop, 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 whoop. What other questions did I ask? What's the limit of h of x? This is h of x. As x goes to infinity, well, I can see what that is. The bigger the number I put in, the bigger the number, the closer it gets to 5. What's the limit as h goes to -3 from the right? Right? From the plus side. Oops, I'm going to negative infinity. I know those answers. Okay. All right, now we're talking about graphing a quick sine function. No, the range. All right, well, you got to know what this is all about. And that's all about the going around the circle. If you make a circle and then draw a triangle, that arc, that length right there, acts like a degree. All right, so this is all about going around the circle. I don't care how complicated this gets. Well, I can get pretty complicated with that actually. So the midline is 9, going up and down 5, up to 14, down 5 to 4. This function is always going to kick out numbers between 4 and 14. Between 4 and 14 inclusive. Okay. I've done these in videos, but have not done one in class with you. They're not hard. -5, negative x plus 5, so -5 and +2 will give you the center, 25, 29, and 40, so radius is 7. Now, where did I get that from? Completing the square, x plus 5 squared minus 25 plus y minus 2 squared minus 4 equals 20. Maybe now you'll understand why we practice this so much. So x plus 5 squared plus y minus 2 squared equals 7 squared. So that's your Pythagorean relationship. Side length of x plus 5, side length of y minus 2, side length of 7. So the center acts like 0, 0. When do I get 0, 0? -5, +2. So that's correct. Can you see that? Of course not. -5, comma 2. And the radius, 7, because you're looking at square areas. Right? X plus 5 squared, y minus 2 squared. You're looking at a Pythagorean relationship. Bounded area, approximate bounded area. Well, you got to know how to graph y equals x. You got to know how to graph -x squared plus 6. So it looks like I got two bounded areas, first quadrant, but we'll take this one. Didn't anticipate that. All right, so this is a height of 6. Got to find that point of intersection. Got to find that x value, or we cannot, kind of guess at what this area is. So what do you think? I guess we could always solve it. We could say, when does x equal -x squared plus 6? Of course, you have to have the skills. So x squared plus x minus 6 equals 0. Looks to me like we've got x minus 2 and x plus 3. So that intersection over here is -3, but we're going to get that intersection, which is 2. Right? And what's that height? Because that gives us a triangle. Let's just do a quick rectangle. Let's just do that. Okay, so this is 2 units, this is 6, that whole thing is 12. That's error, that's error. Nah, I don't know, what do you think? Maybe 7 or 8 units of area here would be reasonable guess. We'd have to do it out, and that's something you'll learn in a future class. Well, maybe you'll learn it in a future class. The reason you might not learn it in a future class is if you don't know how to graph y equals x and minus x squared plus 6, then you're stuck. And just for the record, that's where people get stuck in calculus. All right. And so I don't want you getting stuck. Come on, science cart. Got to make sure we come in under a half an hour on this video. And I said I wouldn't talk. Let's take care of this problem right away. So I have some room for that one. So if you want to reduce a fraction, you got to cancel the common factors. I can see 2x times x squared gets me x cubed minus 1 over x plus 1. And I'm sure nobody's going to miss factoring x squared minus 1, which is x minus 1 times x plus 1 over x plus 1. And yes, sure looks like those cancel. So this fraction, for all x is not equal to -1, but can't divide by 0, is equal to 2x times x minus 1. And I don't care if you leave it like that or multiply it out. Doesn't matter to me. Okay, I got to get an eraser here. At least it's close by. All right, now we're going to look at the average rate of change from 1 to 3 of the ln of x function. And I'll really kind of blow it up graphically. So the ln of x looks like this. And 1, the ln of 1 gets us 0. And the ln of 3 gets us 1.1. So it looks like I have a table where 1 gets us 0 and 3 gets us 1.1, and I want to know a slope. How do you get from 0 to 1.1? You go up 1.1. How do you get from 1 to 3? You go up 2. Sure looks like it's about a 0.55 to 1 ratio of change. We can leave it like this as far as I'm concerned after the concept. All right, bingo, bango, bongo. Real quick, bingo, bango, bongo. Bingo, bingo, bango, bongo, which is 6. Bingo, 10a plus 4. I think you can figure out where bingo came from. Bongo, 12a minus 3, 12a plus 3. Now I'm subtracting 10a minus 12a minus 2a. 4 minus 3, I don't make a sign error there. 4 minus 3 is plus 1 all over 6. I think we reduced our fraction. These problems, once you understand what you're doing, are 3-second questions. 2%, 0.02, triple, 1.1. So that looks like it's 110 divided by 2. It looks like it's going to take 55 years for you to get your investment, which is compounding continuously, to triple at 2%. So let's pretend you put $100 into the bank savings account, e to the 0.02t, and you want to get that triple. All right, I could have made this 3p, by the way, but I think it's probably better for you to see this right now. So that gives me 3e to 0.02t. We've been studying how to solve equations. So the ln of 3 equals 0.02t, tongue twister, and there's your ln of 3 divided by 0.02, which I've done for you over here. All right, now we're going to come in under a half an hour. I don't know, cosine of pi, 5 pi over 6 minus root 3 over 2. How do I know that? Pi, top half, broken up into 6 parts. Well, there's your angle, 150 degrees, and that's a 30-degree reference, so that's a half, that's minus root 3 over 2, and that's 1. Minus 19 pi over 6 is pretty darn close to minus 18 pi over 6. Right, 3 pi on this side, 1 pi, 2 pi, 3 pi. Oh, I'm going negative direction. 1 pi, 2 pi, 3 pi. I want to be at 19 pi over 6. So that means I'm actually at the same place. And this time I want the sign, so we already have it. It's a half. Okay, 11 pi over 4, pretty darn close to 12 pi over 4. Geez, I like 3 pi today. 12 pi over 4, 3 pi over here. And I'm at 11. So I got to break this up into 4 parts. There we go. What am I looking for? The tangent. So that's root 2 over 2, 0.71, negative root 2 over 2, negative 0.71, dividing height by width in the unit circle. I guess it's the tangent, negative 1. All right. I'd like you to be able to get a graphical approximation of this. So let's just get the x-axis at negative 2. Up and over, square root function, 2x plus 1 has a y-intercept of positive 1, which is probably halfway up. That's minus 2, right? And I'm going up to 2 to 1. Oh, looks like I've got a pretty small x value here, maybe around 1 or 2. That's an approximation, and I've got a fictitious answer at the bottom. So let's square both sides. X minus 2. I hope you got better at this. 4x squared, double the product, 4x plus 1. Okay, set it to 0. 4x squared, we're going to do a lot of quadratic solving. We need a lot more practice because the Algebra 1 skills need to come up on this. Subtracting gets us 3x, and minus 2 gives us 3 over here. Oh boy. All right, so let's try 4x first. 1 and 3, will that get me? 1 and 3, no. 2x and 3. 3 gets me 6. I gotta have 2x, excuse me. 6. 3. Oh, I think I made something up really quick here and I made a mistake. So I was like 3 minus 2 is 1. 2 times 3 is 6. To get to 1. Yeah, I don't think that's factoral. B squared minus 4 times A. Oh yeah, this is definitely off. All right, so that's my mistake. I gave you a problem that can't be done. So let's go back and address it and change this to a different number. So let's change this. So let's put a 3 in. That's 1. You can know that. You can learn how I make up these problems. So 3 gets me 1. 2 times 3 is 6. I got to subtract 5. That now gives us a very similar picture, except I'm much lower and still going up at 2 to 1. All right, so it is going to be a greater answer. All right, so let's square both sides. X minus 2, there's 4x squared, minus 10 doubled is minus 20x, plus 25. And so therefore 0 is equal to 4x squared, minus 21x, I believe. Add 2, 27. I'm probably going to start you off with easier problems than this. So it could be 4x, it could be 2x. And I'm going to get hung up on this one myself, I think, because I'm under pressure. 3 and 9. 3 and 9, nope. 9 and 3, 9, 18 and 6, nope. So we're going to go with 1, 27, definitely not. So we're going to go with 4x and x. 3 and 9, 3 and 9 is it. Okay, so minus 3, minus 9. I should have known that if I built it off of 3 that this was a factor, but was not thinking carefully enough. All right, so this is a fictitious answer again, and only x equals 3 works. You can put 9/4 in, and if you do, let's see, making sure this is minus 9, minus 12, minus 9, minus 12. Yes, that's right. Okay, so that works. 4 plus 5i, that's going to become, I put a box there because you can do these problems without doing them out. So x squared minus 8x, 25 and 16. 31. I believe this is where we're going to be. Let's find out. Let's move the 4 over. Let's have the plus minus 5i. Let's square both sides. X squared minus 8x plus 16 is equal to 25i squared. No, I made a mistake here. 41. 25 and 16. Yeah, I said the wrong thing. Okay, so add the 25 to 16, and you get that. If x minus 3 is a root, And let's find the others, then it's also a factor. It's x minus 3 is a root. Then when I do x plus 3 times what? Equals x cubed plus 3x squared minus 6x minus 18. I don't need long division here. Long division, you use it when you can't do it in your head. So x times what is x cubed, x squared? That gives me 3x squared. Oh, that's what I wanted. So I've already set with that. So now I've got to figure out x into what gets minus 6x. And it looks like it's, did I even put the x here? I didn't even put the x there, did I? So x squared, excuse me. So now I need minus 6x, so x squared minus 6. And that gets me the minus 6x I need, and it also gets me minus 18. So x squared minus 6 equals 0 is going to get me the other roots. Then we can see plus minus square root of 6. All right, so we're going to graph that. We're going to sketch it. So we've got a y-intercept of negative 18. I'll call this negative 18. I'm going down at 6 to 1 right there. I need the point of inflection, which is a minus b over 3a, which is negative 1. So over here at negative 1, I'm going to get a point of inflection. I'm going to plug it in and find out what it is. Negative 1, positive 3. Yes, that's correct because I got a 3 to 1 ratio. 2 to 1 in the quadratic, plus 6, minus 18 gets me minus 10. Minus 1 gets me minus 10. This is minus 18. So minus 10 would be about there. Oh. And I have roots at square root of 6 minus square root of 6. So this is the minus square root of 6. This is going to go down, but less quickly, right? And can't really tell you where the local max and min are. I can tell you the x value. Maybe I will do that. I don't know if I'm going to hold you responsible for that. Okay, but we have 3 roots. 1 at the square root of 6, minus square root of 6 is where that root is. This will be positive square root of 6, which doesn't seem like I'm drawing this too well. No, I'm not. So it would have turned very quickly, I think. Negative 3 is over here. I hope I didn't butcher this thing. Add this up again. That's correct. That is correct. That is correct. So 9 minus negative 9, 1 negative 10 is correct. So it concave down until here, then concave up again. So it's really much closer here, square root of 6. All right. And if I wanted to, I could probably get through the x value here really quickly by finding the slope at the point of inflection, which is c minus 3ah squared. It's taking me longer than I thought to do this video. So that's c is minus 6, minus 3, a is 1, h is negative 1. So that gets squared. So it's going down at 9 to 1 here, right? And then it's going to turn pretty quickly because those two terms are going to take over very quickly. So it's a condensed graph there, but at least we found out some stuff. And over here, this x value would be h, which is negative 1, minus the square root of positive 9, the opposite of that slope at the point of inflection, divided by 3a, which is 3. And we know that. So that's minus 1 minus the square root of 3 is approximately 1.73. Well, that's helpful because that tells me that this is now negative 2.73 right there, and that's positive 2.73 there, if I graphed it better. Woo! Sorry, folks. Didn't expect this to take so long, and I feel like it's hurried, but hey, maybe it's good practice. Who knows? So I'm going to graph this really quickly. So I want 3x equals 0. I want it to equal 2 pi. And so I'm starting at 10, going up to 12, down to 8. Cosine function, max to max is the easiest way to do it. So that's 0, 12, and that's 3 into 2 pi. 2 pi over 3 is going to be the period is 2 pi over 3, and that's going to bring it back to 12. And now you got all kinds of symmetry. Okay, that's pi over 3 gets you 8. And I suggest you plug those in and see why. All right, sine function, you're better off starting in the middle. That's one period of the sine function. 5, 7, 3, so our range, 3 to 7, inclusive. I can make a 0 with a 3. And if I divide 2 pi by 1/4, that's a shortcut for finding the period. So that period right across there is going to be 8 pi. So we're going to be 8 pi past 3 to bring us back to 5. Okay, and then there's symmetry here as well. So that would be 3 plus 4 pi. This would be 3 plus 2 pi. It's going to get me 7. And I suggest you plug that in to see why. All right. All right. ln of 20. Let's use rule of logs. ln of 20 is equal to the ln of 4 plus the ln of 5. The ln of 4 is the ln of 2 squared plus the ln of 5. This is 2 ln of 2 plus ln of 5. And if you're not part of the class, you might not know those values. Pause the video and look at it. 2 times 0.7 plus 1.6, I believe is 3. So therefore, e cubed should get you pretty close to 20. Now let's do it organically. So 20 is 4 times 5. 4 is 2 squared times 5. 2 is e to the 0.7, roughly squared, times e to the 1.6 is getting us the number 5. What am I doing? ln is all about what I'm doing exponentially. I'm doubling 0.7. There it is. And I'm adding 1.6. Right. So if a product, well, a product gets us addition of exponents, well, here's the product. So that gets me x squared minus 6x equals exponential form, 4 squared. So x squared minus 6x minus 16 equals 0. X minus 8 times x plus 2 equals 0. We don't care about x plus 2 because domain restriction. This has to be bigger. Actually, my answers have to be bigger than 6. 8 is bigger than 6. That should work. 8. 8. Okay. What's the exponent on top of 4 that gets you 2? 1/2. I'm square rooting 4 to get 2. I'm square rooting 4 to get 2, and then I have to cube it. So that's 3/2. And 3/2 plus 1/2 gets you 2. There's a quick check. Come on, science chart. We got another. Woo! Am I coming under 30 minutes on this? God, I hope so. Yeah, but it's practice. You need reps. And once you get the reps and you know what you're doing, you're saving yourself a lot of time. Exponential function, y equals 6. Base is 1/2, so it's an exponential decay. We're going to start at 3. And we're going to get an initial jump of 4 on top of 6. That's going to be 10. And then we're looking at the next number is 8. That's friendly. Right? And 8 is going to get me half of that first jump. And half of that first jump is 2 units. The first jump was 4. The next jump is 2. Next jump is 1. Okay? And so therefore, I'm getting a jump of 2 on top of 6. 8 gets me 8. Logarithms. Asymptote. That's got to be positive. So I'm to the right of 4. It's got a base 3, so I know it's an increasing logarithmic graph because that's positive as well. So I'm going to plug in the number 9 first. I want to get a 1 because I know log base 3 of 1 is 0, which is going to get me 6. And so what makes that? 9 gets you 6. Okay, and that happens to be 5 units, by the way, 5 units from 4. Next one's going to be 15 units because it's going to be 3 times. So what do I want? I want the number 5. I want x minus 4 over 5 to equal 5. Well, 25 and 4 is 29. 29. 29 gets me 25. I want that. 9 minus 4, 5. I wanted that. I wanted 4. And I want this to equal the base. I told you I get tired, so I want to make that. That still works. Let's get it equal to the base. And then I'll get that 5. Then I'm going to get that 15. So let's make that x. I'm tired. X minus 4 over 5 equals 3 is what I'm after. So that's 19. Okay, and what's 19 minus 4? There's your 15 units. Okay, so 19 gets us 2 plus 6, 8. All right, there's some real patterns here. Okay, I like to work with 0 and 1.1. What makes a 0 a 2? So asymptote of 4. My first jump, I'm going to make my first jump 5. I'm going to make my second jump 15. I like 3 to 1. Okay, what's gonna get me 9 units? I'm making this a 0, which is a 2. What's gonna get me 15 plus 4, 19 units? 19 units, these don't really exist. I gotta set this to 1.1, right? Either the 1.1 is gonna triple this 5 units. 3.3 plus 2, 5.3. There you go, there's a practice on that one. I'll put this as an approximation. ln, I like the ln of 1, and I like the ln of 3. Those are easy numbers to work with. ln of 1 is 0, ln of 3 is 1.1. Notice I'm not doing transformations. So x equals 3. I'm doing change from a location. Negative ln is going to go the other way. 1, what makes a 1? 4, 7. I'll put that right there. 7 gets you 1. ln of 1 is 0, so you're going to get the 5. Now I want this thing to equal 3, so I'm going to pick 15. 15 is way to the right. And if I put 15 in, I get ln of 3, which is 1.1, which is minus 2.2. Take minus 2 away from 5, you're at 3. Take another 0.2, you're at 2.8. Roughly, just to get a numerical feel. Almost done. Almost done. Again, practice these daily. Each problem, it's just a minute or 2 each day. Then before you know it, 4 or 5 days have gone by, and you don't have to think about doing these anymore. You can look at that and say, oh, that's an ellipse. 3 to the right, 3 to the left, 2 up and 2 down. Center, at. Center is at 2, -5. I go 2 up, put a 2 in, you're going to get -3, friendly. Oh yeah, 2 gets this to be a 0. I was looking at that one. All right, and if I go 3 to the right, 5 gets you -5. And -5, very friendly number there. And this one gets you, well, you can do those two yourself. All right, 3 ways to write this sinusoid. What would be the easiest way to write this one? Probably a negative cosine. All right, so therefore I'm the midline 20 to 34, 54 cut in half, 27. Up and down 7. I want to go down 7 first to get to 20. And I'm going to do a cosine curve. And I got 1 pi, 2, 3, 4, 5, 6, 7 pi. Oh, I like the number 7 here. And that takes 50 years. And that's going to be starting at 1950. Numbers are speaking to me. I could have also made it a sine curve by adding 7, because I know that at 3 pi over 2, I get -1 for a height. And so I'm going to make this thing at 1950 go through 3 pi over 2. No change here, 7 pi over 50. No change here. But I'm going to start at 3 pi over 2. What's another way to write this? Should we go back to a cosine? Cosine, we already did a minimum. Is there anything that's easier to do here besides those two? I suppose I could make it the cosine if I do 27 plus 7 for the same reason I'm doing this. Cosine of 7 pi over 50, x minus 1950. And the last thing I'll say is when you put 1950 in, didn't need that second parenthesis. Yeah, I did. If you put 1950 in, you get 0. Right? The cosine of 0 is 1. Cosine of pi is -1. That's what's going to make this addition of 7 become subtraction of 7. So I want to add pi here. That's just another way I could have written the function. All right, I tried to go fast. You were going to stop the videos and try them a little slower pace, but then you could just check your work. I don't know if that's an effective video or not, but I am a big fan of reps, and there's an opportunity here to get some. And if I made a careless error, write to me, and I'll make an addendum, or I'll make something in the comments that says you spotted. I'll even give you credit. Put your name out there if you want it to be out there. All right. Ciao.